In this video, we'll look at Rafay's Gen AI Workbench. Let's start with the high-level architecture. As you can see here, multiple developers are working off the same unified platform. Let's look at some of the benefits of this platform, and we'll look at that in deeper detail in subsequent videos. Let's start with centralized storage namespace management. Okay. As an administrator, you can go and create storage namespaces, and these can be shared with multiple users in the company. Let's start by creating a storage namespace, and as you can see here, these can be backed by various kinds of object storage types such as S3, MinIO, etc. And as an administrator, just provide a name and provide a location, and then save the namespace with the credentials. Next up is foundational models. This allows an enterprise admin to curate and manage a number of foundational models in a company. In this case, as you can see, there's about 10 models, foundational models, that have been uploaded and saved in this Rafay tenant. These can be used by any of the users in the organization. To create a new foundational model with all the details in it, just select a project, provide a model name, and now specify the storage namespace. The entire model, even if it's hundreds of gigabytes, is downloaded and cached and stored in the storage namespace that is available instantly to users that need to use it later. Now let's move on to enterprise dataset management. This process allows the admin to upload the data, enterprise data, and make it available to users for Gen AI experimentation, etc., in a secure manner. To do this, we'll click on datasets, and then we will upload local files in our particular case, and we'll start with specifying a particular project where we want to make this available. We'll give a name to the dataset. We'll specify a storage namespace where the dataset will be stored, and we'll specify the kind of dataset among the various types and the format. And now we'll land up uploading, in this particular example, I will use a simple CSV dataset, but you could also use a CLI to upload it directly to your S3 bucket, etc. Next up, we will use our foundational model and the enterprise dataset to fine-tune the model. We'll start with the fine-tune job, and we'll select our model, and we'll have to provide a name for the fine-tuned model, which is our result. So we'll just give it a name. And then there's a bunch of settings that you can specify to optimize your model configuration. We call these advanced settings. So in this case, we're going to run the first job, fine-tuning job. You can have multiple jobs. We'll give it a name, give some settings again. And if you want to quantize it, you can, to increase performance and reduce size. And let's continue our input data here. Now we'll provide the input data, and here we go select our data set that we just created. And then optionally, you can also provide a validation data set, which will allow you to test if fine-tuning is actually working or not. And then we will submit our job. And then we have to specify here, once our fine-tuning is complete, where do you want to store it? What name do you want to store it as? So in this case, we have picked a certain location, the particular thing, and then now we have to specify which cluster we want to run this in, and possibly a namespace, and then ask for resources. In this case, we're just going to use 1 GPU for our fine-tuning job, given it's a small model, and then we will submit our job. And once we finish our fine-tuning process, as you can see here, our fine-tuned model is now available in this list here. Now let's look at how we can perform a zero-code inference or serve the fine-tuned model that we just created. So for this, we'll go into inference, and then we'll select our new fine-tuned model that we just created some time back. We'll give it a name for the inference, and then we select a cluster in a namespace where this should get deployed, and specify what kind of resources I need to run this inference server. And then that's it. In a few seconds, you'll have the entire service up and running on that particular cluster. Notice there was not a single line of code the user had to write to do this fine-tuning. Now, the platform also provides an integrated playground where the user can test their fine-tuned models. Let's try this out. Let's go to Playgrounds and Chat, and let's go select our model that we just, the fine-tuned model we created, and then you can enter your prompt there, and you can try out various configurations and various prompts to see if your fine-tuning actually worked.